This time we'll be looking at half-life and how we can use the equation we derived to calculate certain things. And here we have a problem. 1 gram of radioactive material having a half-life of 2 years is kept in a store for a duration of 4 years. Calculate 1, the decay constant, 2, how much of the material remain unchanged. So when you look at this, like I always say, in physics, you need to write out, identify what and what that is given. So the first question, we are looking at the decay constant. And what is provided here is the what? The half-life. A half-life is T, 2 years. So we know that this is given as 0.693 all over lambda. And making what we are looking for here is lambda. So lambda now becomes 0.693 all over 2 because our half-life is 2 years. So by the time you divide that, we'll be having 0.3465. 0.3465 per year. I have 0.3465 per year. We're done with the first one. The second one is how much of the material remain unchanged. Now, this is where we now deploy. This is where we now deploy that formula we derived. N equal to N naught E minus lambda T. How much? Let's look at this question very well. 1 gram of radioactive material having a half-life of 2 years is kept in a store for a duration of 4 years. That is time. So in this case, T is given as 4 years and N naught is given as 1 gram. So by the time you substitute this, you have N is equal to 1 times E minus, remember we have calculated lambda to be 0.3465 times 4 times 4. And by the time we multiply that, we have 1.386. We have 1.386. N is equal to E minus 1.386. 4 by this will give us this. So by the time we do that, we can write this as N equal to E, that is 1 all over E 1.386. This is exponents. We can get this from your calculator, and by the time you divide the value you get here with 1, we now have 0.25 kg. That is the value that will remain, 0.25 kg. And with that, we have answered both question 1 and 2. Thank you.